name is Ted. My name is Iguantin, and my supervisor is Takayuki Nagai. My topic is convolutional neural network based on embedded system. And here's my outline. First is objective. I will talk about what is my main goal, and second is background. Is what is the convolutional neural network and neural network. And introduction is the neural network method is what I'm doing in this paper, and challenge is what I've learned from during this paper, and result, and conclusion, and future works. My main goal is transplanting the learning image recognition library algorithm into the embedded system. And in the robot computation, there's a many tasks and need the image recognition, like RoboCop software, like this. And this robot is to detect where's the ball and walk into the door. And sometimes the robot is really small, like the quadcopter, and it's so small, so they cannot put on the laptop or PC on it. And also the image recognition is very heavy duty on the computing. So according to this, we use the embedded system, we so-called small computer, and embedded system which we need is the powerful CPU to deal with the image processing, which is better need to have a parallel processor. So we need the GPU or parallel processor. And sometimes because the robot is so small, so we need the embedded system to be small, and the power saving because the robot is so small, so it cannot have carry the very big battery. So our solution is the parallel board like this. It's so small, is the hand size. And the parallel board is they use the dual-core 9 processor, and they have a co-processor is the multi-core is 16 core here, and the size is the critical size, and the power consuming is less than 5 watts. Now I'm talking about the image recognition. There's two methods. There are two methods. One is traditional method, and the other is the learning method. And traditional method, we need the mathematics model to define what the object will look like, and it's very hard to describe to build about a math model. And in the other way, the learning method is we don't need a model. We just teach the program how to learn the new things, and the programming will learn this method and will recognize the object we want. And this is the typical neural network structure. Why we need to use the parallel processing because it's like this. If we use the CPU mode, it's serial processing. Each circle is a node, so you will, like this picture, every node you will multiply, so you will not 1 unit to 1 unit, so it's very time consuming. So like this structure, they will take 200 steps to process all the units. But in the parallel mode, if you use the GPU, and you will take 3 steps because GPU is very good at this. It can process in the one day in the one time. I'm talking about introduction about the neural network. A neural network has the two types. One is shallow learning, and the other is deep learning. And shallow learning is the layer is less than 3 layers. We call shallow learning, and this is the architecture. And here is the input, and here's the layer, and the output. And the output is the mathematics is the weight. W means the weight plus the input and add the bias. So this is whole things. And we need need the thousands of samples for training the thousands of samples to train the neural network that they can produce something, they can do the image processing. But if the sample is too much, the accuracy will decrease. And we use the deep learning is the CNN convolutional neural network. The benefit is the more sample you use, the more accuracy we get. It's the architecture is kind of same, but it's different because they have many layers. Like here's these 7 layers, and here is the convolutional neural network system architecture, and here is the input image, and we do the convolution here, and you will get the input image, and you will get the feature of the picture. And after we got the feature maps, and we do another math is the subsample. Subsampling is to maintain the feature, maintain the information of the picture, but decrease the dimension. So it's more easier to process. So convolution is here we got the feature maps, and here we do the convolution again, so we got the feature of the feature. So many steps of the convolution, we can get more details about the picture. And the end the result and the end of the layers is the full connected. And here is the convolution processing, and this is the origin picture, and after convolution you will be here like some edge information, and this is how it works. We use the 3x3 mask to produce another feature maps. And this is how it really works. So first we input one image and convolution one time, so you will get the features, the edges and the colors. And the second we get more features, and here so we got 5 convolution. So in this part we are doing the feature extraction. So in the convolution 5 we got many features. And the second part is the classification part. So and after convolution 5, and we connect to the full connection. Here is to classification the features, what the feature is, and the result is that here after we full connected the 7, the result will be the after classification, and this is the possibility. And the code is to get the top 5 possibility to show up what's this or this is. So the picture is a cat, and he knows because the category has many type of species of cat. So it's top 1 is a tabby cat, tiger cat, or Egyptian cat. So it will be here. This is the top possibility, and the axis is the number. This will directly to connect it to the name of the category. And these are feature maps. This is all the edges, and every picture, every part of the picture is composed by the weight of the features. So we can use 3 edges to compose to the small part of the picture. And CNN is kind of like the human brain. We also have the input image, and the lower feature is the edges, and we do again the middle layer, middle convolution. It will be the part of the face like eyes, elbows, ears, and the higher one is the human face. So we can, if we put input some Mary's face, and the system will know this picture is Mary. And in this picture, we can know is all the input is all the same edges, and we can multiply the weight and bias, so we can get the different things like cars, face, elephants. So first one, we input the image like the motorcycle. Like here, the orange data is all the pixel. And after we feature extracting, so we got many features, and we do the classification. So after classification, we can know what's this. The classification is like they have feature is 2 wheels, 1 handler, and 1 tank. So the classification will be the motorcycle. So in this paper, I'm using the CAF library, which is the deep learning frameworks is created by Berkeley Vision and Learning Center, and it's the pure C++ and CUDA architecture for deep learning. We can use the command line, Python, MATLAB interface to develop this program. And it's very easy to set the neural architecture, and it's very easy to switch the CPU and GPU mode. Like this is how easy it is we just edit the text, just edit the type, what the layer is, convolution, the subsampler, and the output, the architecture just like this. And every layer they got parameters. So like what method we use and the connection. The bottom one is maybe input, the output one maybe the first layer or second layer. And here is the mask we can decide. And this is my program structure. I use the web camera to input the image and use through the USB and send into the client. The client is use the Windows, and the client will convert the string image to the JPG and send the image through the internet to get into the server. Server is the Python, and I also use the Linux to test it on the PC. And after classification, use the CNN and will return back the result, what the picture look like, what the picture is, and send back to use the HTML file. The challenge is what I learned during this paper. I learned because neural network is very new to me, so I have to learn all the neural network and the convolution neural networks, all the theory, and the Linux. The hard part one is to environment setting. They have many. If you set row parameter, maybe you can run correctly the CAF library. And Python, I use the Python to develop the CNN. And JSON is to set up the website, so I can use the Windows to send the image to the server, and transplant of course, to transplant the CAF library into the parallel board. And the hard part one is to use the CMake, the OpenCV. The CMake is this program is to make the makefile, and we can use the makefile to compile the whole OpenCV program. And this one is the parallel coprocessor, the language. And result is I use the ImageNet. The database is from the 2012 challenge. We got the 10,000 category, and every category have the 1,200 image for training. All the image is 12 million is this big, and I use this to train all the database in the GPU mode in the 1 week. So the picture is the database look like. So you got many like mammal, a dog. And dog have the main species. So this species is the husky. So he got many husky picture, and I can learn the species. And this is my result. I use the CNN to detect the frog, the tree frog, and this Fujisan is the volcano. I set up the web server and I open the Python to do the classification to the internet. So here we got the top noodle. You can see this the bottle or container, and this is the glass. Because the lights it will disrupt the result. So after that, I will change it to this is the bottle, and I will change it to mouse pointer device. So I put all the image on my small computer, so that they can make the problem more simple. So here is a tree frog, so we got more accuracy. Tree frog and Fujisan, so they said this is the volcano. And this is a scorecard. Here is scorecard, then later this things, then mountain tanks is flower, and power drill, all the power drill, and jellyfish is room one. This is the nuclear power plant. Because you don't know what's this, so it also corrects the structure or castle and the lion. And I also use the RCA, it means the region of the convolutional neural network. This method is they can detect the object, where the object is, and it can detect object in the center. In the picture, maybe I take a picture in the street, so I can detect in the same time like cars, structure, or human something. And I implement in the parallel board is 24.2 seconds. It's kind of slow, and also run on the PC. The GPU is 189 faster than parallel board. The CPU is almost 10 times faster than the CPU board, than the parallel board. The conclusion is that I can run the CNN on the in-base system and successfully transplant the UCAF library into the in-base system. But the CPU mode is not fast enough, so I have to run in the multi-core. The future work is run the parallel board in the multi-core because the CAF library they use the CUDA, but the CUDA is only supported to the NVIDIA graphics card. But the parallel they have their own multi-core, so I have to change all the CUDA program into the multi-core language. And this is how the efficiency is. This is the very linear in the 60 core and almost 16 times faster. This is very significant because in the cluster or in the GPU, if you don't set the right program structure, or the CPU structure is not good, or your memory setting is not good, you cannot get this result. So I expect is using the parallel board in the multi-core. Multi-core will get almost 16 times faster. Thank you for your attention.
Okay, thank you very much. Now we have time for questions. So,
thank you for your presentation. My question is about you say that you have to extract the future of the image. So which kind of method do you use for to extract the image, or you use whole
thing is use CNN.
Whole the picture?
I mean the picture extracting and the classification is all the CN, the convolutional neural network method. In the technical way, in the traditional way, we use the feature like sift or serve to do the feature extracting, and maybe we use the SVN to do the classification. But in this part, we do all the feature extracting and the classification in the CNN, in the convolutional neural network. Here, in this part is the subset polar and convolution layers. Here is the feature extracting, and the full connected is the classification. So all the method is the convolutional neural network. So I just use the one method to do the all things.
Thank you.
Right, another question?
My question is also related to the car. I understood from your presentation, I understood that convolution layer is basically a spatial filter on the image. Is that right? Okay. So you are applying several different spatial filters to a single images. Then I think you may need supply the original data in parallelly to each of the convolution layer, because it is showing the sequential. You are applying a convolution layer sequentially. That means, for example, at the first layer, you might pick up on the edge information by applying high-pass filter and so on. Then supplying that result to a next layer of a convolution layer, which might be a low-pass filter, but you have already lost the lower frequency component in the first layer. So you have to provide, well, that's my idea. You may have to provide, supply the original data in parallelly to each convolution layer. Is that right? Or maybe I'm misunderstanding.
It's not right. It's because we have to, the feature of feature means we got the in like C3 the feature means this feature is get the feature from here, so we must do the C1 first, then we can do the C3 second. So we have to do this first, then here, and in the parallel mode is means in the sequence, like input the image and do C1, do C2, S2, C3. Every step is in the CPU because they have the steps. CPU can do this because this is power. But if GPU is in the side is to do the math.
Yeah, I understand the structure. But what I'm asking is probably at the first layer, you might already lost the useful information for next layers. Okay? Well, sorry, I might be misunderstanding you. Okay, anyway, thank you very much.
So, okay, there's a question here.
Thank you for your presentation. What's the main advantage of the convolutional neural network compared to another kind of neural network, for example, backpropagation?
You mean the
advantage of
advantage?
Yes.
The advantage is we can directly learn the image, just use the same method. Other architecture is they have to compose to another method in that. But convolutional neural network, they can do all the things just using the convolutional neural network. So it's more simple.
Oh, thank you so much.
So I have a question. What's the main motivation to use parallelabort?
Because it's small enough and it also have the multi-core, so we can implement all the image recognition into like this small soccer robot, because they have to detect the ball, where's the ball and where's the door, so we have to be very small ball onto that. Maybe maybe have some embedded system like TK1, they have GPU, but the board is too big, like CPU big. The CPU main motherboard, the CPU PC motherboard big, so we cannot implement on this small size because this size is just this big. The robot is just this big, so we cannot put on this.
How is the actual size of the parallel like?
Critical size, just this big. Critical.
I see.
Yeah.
Well, because it was related to that, because one of your problems right now, I think, is to, how to say, you use CUDA, right?
Yes.
So Tegra K1, it's
Also use the
you usually use CUDA, and it's, well, not so small, but considerable small.
Yes.
So I think that will be, I think, advantage if you just port it.
Yes. But this is too big. This is
Okay, I
not
see.
my motivation, so I said I have to change all the CUDA core into this language.
Okay, that's a challenge.
It is a challenge.
Okay, thank you very much. So any other? No. Professor Takayuki Nagai is here. No. Okay, so thank you very much for your presentation. So we are going to have a break, 15 minutes, I think, and it's going to. We are going to start again at 3:10. So please be here minutes before. Thank you.